So today let us begin a new chapter on the coupling and cohesion, right. So yesterday we had discussed the system design initial things, the basic ideas about what are the basic components of system design. Usually there are three things. One is that of user procedures, DBMS, database management systems, and finally the automated systems. Now in the automated system design, basically we are discussing about how to divide the automated systems into well defined modules. So we are in the middle of this particular slide, that is, a module is a group of statements having a single name and treated as a unit. Some problem? Okay. Anyway, you can just read it out, or I think someone go and tell. So cohesion is how well the activities within a single module relate to one another. Right. Separate modules should be relatively independent, that is loosely coupled. This facilitates development maintenance by teams, reduces chance of unintended ripple effects on other modules while changes are made to a module. This we had already discussed in the previous class, right. Now there are certain guidelines which actually decides what should be there in a module. So some of them are: a module should perform a single task with single entry and exit points, right. That is the first one. The module should perform a single task with single entry and exit points, right. That means there should not be multiple entry and multiple exits. That means all the inputs and all the outputs should be coupled together and they should be entered at a single point of time. The input and output routines should be separated out into a small number of standard modules. So basic idea here is that whenever it comes to the your various input and output handling, because you see for every software development there comes a certain number of modules which will be common to all the modules. You know, something like if there are number of subsystems, there will be certain things which will be common to many. So these should be defined in some standard functions or routines or classes or objects or whatever, and they should be basically some standardized things. Then system dependent functions should also be isolated in order to improve portability. I have discussed portability in my previous class. The basic idea is that due to many reasons you may have to do some platform changes, and these platform changes, let us say from maybe Windows based system to Unix based systems, or even in Unix based system you may have one kind of machine like HP 9000, you may like to go to something like Solaris. So between the Sun Solaris and let us say the HP 9000, although 99.99% things should be the same in Unix and whatever is your programming language, maybe C++ or C, but there will be at least 1% difference. I mean not really 1%, say 0.01%, a small percentage would be different, and because of these differences those are maybe called your system dependent functions. So you should take special care that if you are going to use some system dependent things, you put it in a different module, so that when you go to the new system, all that may be required is change that particular module and not the entire thing. Always aim for trade off between functionality and the resources available. So usually what does it mean? That meeting the business needs and the constraints, that means you may not have resource available. Suppose there are not lot of the hardware, that is required hardware is not available, and you basically require certain things. For example, you require very high speed computation, maybe there is an online simulation and you want the simulation to proceed at a very fast manner. Now, you may ask that how important is for me to have a very fast simulation? Is it more important, or it is more important to make these simulation available to more number of people? You see, many a time what happens that whenever you are running a simulation, the simulation is a back end activity, all right. It may be run by a group of people at the computer center itself, whereas the output of the simulation, maybe the simulation of manufacturing or some other things, might be important to a large number of people, all right. So, suppose in the name of speed, if you buy a very high end machine with very high speed, etc., simulation will be carried out very fast definitely, but because of lack of budget or whatever, you cannot buy adequate terminals and give it to all the concerned people who actually require the simulation output. Now, you have to weigh what is more important to us. Is the simulation running it very fast is more important, or giving it to all these people are more important? If you think giving it to all these people are more important from the company's point of view, then you can always schedule the simulation runs towards the evening or something like that. You should go for multiple terminals rather than high speed. So, this is the basic idea, that trade off between the functionality and the resources available, and accordingly you decide your modules, right, which module to develop and which are not to be developed. Then there are a set of criteria known as Parnassus criteria. So, basic idea about Parnassus criteria, there are 5 basic points for modularization. The first thing is definitely primary goal of decomposition into modules is the reduction of software costs. So, one need to reduce the costs of the software to be developed. But there are some specific goals. The first one, each module structure should be simple enough to be understood fully. It should be simple, that is the first thing. Each module should be simple. Then implementation of one module should be independent of other modules and should not affect their behavior, right. So, sometimes what happen that if you modularize in that manner, suppose you want the salary. Let us take a simple example of salary computation. In salary computation, there are essentially 2-3 major components. The first one is calculating the gross salary, basically the basic of a person, then dearness allowance, then your other pays, HRAs and so on. This constitutes the gross salary. Then there are the deductions. Now, usually what happens, there are large number of deductions, right, large number of deductions, say provident fund deductions, family pension deductions, then there are hundreds of things like loan repayments. If a person has taken a number of loans, then repaying those loans, or sometimes what happened, a person may be member of some clubs or something. Now, please try to understand what actually sometime can happen is that you suppose you make the module like this, that one module does just the gross salary calculations, right. Another module calculates the all the details of the individual deductions. Say we have small modules which calculate all these individual deductions. Then what happens, you also after now you have a large number of modules which are basically utilized for gross computation and the individual details computations, right. But individual results are stored in each of them. Now, suppose you have to define a module which will calculate the net salary. if you do not think about a something like a database where each module would put their data and basically you would read from the database. Suppose you do not want that sort of a design and you have a design where a person has to read through all the modules and collect output from each of these modules. All the modules goes to a single module and this final module calculates net salary. I do not know whether you are clear about this or not. Basically what I am trying to say is something like this. You see, suppose you have a structure of this type. Now see, this calculate net salary, if you have to do this the way it is shown here, then you have the gross salary coming from here, you have the deductions coming, 1 coming from here, deduction 2 coming from here, deduction 3 coming from another. Then suppose due to whatever reason the net salary is wrong. Now the error is could be here, please understand, error could be here or in any of these modules. The problem may not be here, problem may be in any of these modules. So it will be very difficult to understand where the problem is. Not only that, the person who has to write this module has to understand each of these top modules, alright. So this is the difficulty. A much better design would be that individual calculations of gross salary or individual deductions should actually go to the database, alright. Then from the database you can obtain all the relevant details and calculate the net salary. So what actually happens is that when you are calculating your net salary, you need not understand what is wrong in the others. You simply know that this is my data store, I collect the data from this data store and put it back to that data store, right. So in that sense the modules are independent of one another. Then the ease of making a design change should be related to the likelihood of the changes needed. So basically what it basically says again is something to do about functionality. Usually what happens that whenever you are going for the design change, all design changes are not equally important, alright. So there is a word, if you recall, I have said right in the beginning, that is requirements gold plating. Gold plating. The basic idea is that see, there is nothing like 100% requirements fulfillment, you cannot do. There is you can maximum do 99.99%, not 100%. There will be always some more requirements which you could not meet. So it is necessary for the requirements of the design changes to be hierarchically sorted out according to their importance, according to their need, and try to focus on those design changes which are required the most. Then major software changes should be possible to make with independent changes to individual modules. So, this is important. See, ultimately your complete software, suppose you have to make major changes. Now, conceptually whatever you have done, but end of the day the changes should be coming out of individual module changes. Again the idea is the one and the same, that how to make use of more number of people, how to improve productivity. The responsibility of a module should be understood without understanding the module's internal design. I think you understand the difference between responsibility and internal design. What is the responsibility here has a very specific meaning. Basically the meaning of responsibility is that what the module is supposed to do, what are the messages that the module need to pass to other modules. Alright. So, suppose one module is connected to 2-3 other modules, then what messages or data should be passed to those other modules, and why this message or data is to be passed, so that the other modules can perform something. So, in that sense this is the responsibility of this module. Is it clear? So, this is the idea. So, basic meaning of this particular word is what a particular module should send data or pass messages to other module should not be, suppose you want to understand this, it should be possible without going into the internal program logic of that particular module, is it not? See, in today's world we talk about see, basic idea it can be understood this way. Suppose you have a TV remote, right. Now, these TV remote, the technology of this TV remote most often has nothing to do with the design of the TV. You can change the television, you can put another television which internally may work totally differently, the technology is totally different, even how it handles that remote signal is totally different. The earlier television were handling the remote signal in one way, right. The new television is again handling the same remote signal, but in a different logic by using a different technology. But you do not have to worry about this, even if the technology within the remote control may also change, alright. How it generates signal, and when you press a button 1, what happens inside, you need not know. All you need to know is I press 1, the TV comes on, alright. So, this is the responsibility part, it sends a message, that message has something to encoded as 1, is it clear? So, this is how it can be done. So, this concept will be again coming, we shall come back to this when we go back to the object oriented programming and object oriented analysis and design. Now, before we move over to coupling and cohesion, one or two simple things. First thing, there are certain basic guidelines of whenever we design a program which are to be followed. The first one is it should be a top down approach. Top down approach. Top down approach means basically there are two approaches whenever you are designing a program. Basically it could be top down or it could be bottom up, right. So, bottom up means you try to look at the program from just look at the individual tasks, alright. But if you do like that, you develop lot of individual programs, but when you have to combine them all, you find that it is not possible to put them together. It is difficult to combine the programs into a single cohesive application. Why? Because the interfaces will not match, because changes in one program might affect another program in an adverse way, alright. It will not be an integrated development. Then structured programming. Basically what is known as structured programming is, there are three basic coding structures: sequence, selection, repetition. I think you know that, we have also discussed. Sequence is that the statements are executed one after another, selection if then else kind of logic or switch kind of logic, and repetition looping, do while, etc., while, for. Then there has to be a programming team. There has to be a programming team. Usually there are, we have discussed, I think there are basically chief programmer team and democratic setup, egoless programming, etc., etc. Then we should have a very important thing, a facility for a structured walkthrough. A structured walkthrough is a very important quality tool for any program development. What happens whenever you have designed a module or a program, there should be a regular quality inspections, and usually who should form these quality inspection teams? It should be the developers themselves, a group of quality experts, the project leaders, etc., etc., and they should go through the code and try to understand whether there are some errors, right. So sometimes what happens, the error may not be within the program, or looking at it from that point of view, really you do not understand where is the problem. See, basically a work can be done in 100 ways, alright. Now it is only a given way which is going to be amenable to all the other work, right. So if you are doing in one of those 100 ways, you feel you are doing it correctly, is it not? But problem is, when you go to the, suppose you are handling some 100 papers, alright, which are numbered 1 to 100. Now you can put it serially, you may not put it serially, or you may put it serially but backwards. So when you put it backwards, you have sorted it, is it not, but backwards. But the next operation requires it to be sorted from 1 to 100. What will happen? The next operation will suffer, because it does not know how to handle backwardly sorted numbers. It expects the numbers to be coming in 1 to 100 sequence. So it is a mistake in a sense. See, it is not really an error as far as you are concerned, you have sorted it, but the next program will face difficulty. So these kind of errors will also be seen in the structured walkthrough. This is basically a kind of inspection only, but is an involved one, right. Then there should be development support libraries. There should be two types of libraries. One is basically for enhancing the knowledge of the developers, and the second one basically where the standard libraries or standard functions, standard classes, objects which you can borrow to your application. Then there should be a visual table of contents, an overview diagram and a detailed diagram. These are actually what is known as hypo, hierarchical input process output charts, hypo charts. I will not go into detail of hypo charts. Basic idea about hypo chart is that it shows the input, process, output. What are the inputs, what is being processed, what are the outputs in detail, right. So when you show them in a summarized form, you can call it an overview diagram. When you show them in great detail, you can call it a detailed diagram. Then there should be indentation by comments. very important. Without proper indentation, the program is unreadable. And finally, there should be less than 50 lines per module. There are some specific requirements about a good computer program. A good computer program should be, it should meet customer needs, it should be developed in time and within budget, it should have error free set of instructions, right. It should have a facility of input editing, there should be control of errors during processing errors, and it should have maintainable code, and finally it should have portable code, right. So, good computer program should have the following things. Now, certain important things, I mean, it should meet customer needs and developed in time and within budget, should have error free set of instructions. Now, what is input editing? What is input editing? The input editing is like called input validation. I think I have used the word validation a number of times. The basic idea of validation is that you see every field, suppose a particular object like a student has got a number of fields, is it not, or data items, attributes, key elements. So, suppose it has a roll number, it has a name and hostel and so on and so forth. Now, each of these particular field or data items has got a domain of values. What is meant by domain of values? Say for example, your roll number. Any number cannot be your roll number, alright. The roll number should be now how many digits? 7, 8 digits. So, it should be an 8-digit number, right, and these 8-digit number, out of that the first 2 digits are supposed to be the year of joining. Now, since the present batch of BTech students shouldn't have joined, I think reasonably beyond 97, 98, right. So, if someone's roll number who is supposed to be a BTech student begins with something like 96, 95 or 85, it should be a wrong one, right. So, it could be a kind of validation, right, it should be a kind of validation. That means, we can always specify that the roll numbers should not begin with no lesser than 95, let us say, or no greater than 03. So, the number should be 0, basically 04 to 95 is ruled out. The first 2 digits should not be between 04 to 95, is it not? So, 96, 97, 98, 99, 00, 01, 02, 03 are the allowed numbers. Now, we can again do some more checks. For example, if the student is in second year, then we can again make some more validation, alright. So, these all are part and parcel of input editing. So, whenever you are receiving some input, the input should be edited. Now, what happens? The input editing was a very important thing in the earlier day COBOL programs or Fortran programs or even C programs, but with the advent of database management systems, this has been tremendously reduced. What has happened? Nowadays, most of these input editing should be taken care of by the DBMS itself, right. But however, even if you have a DBMS, you have to enter the data into the DBMS, alright. The DBMS, the data should actually first you have to fill it up, only then you can be used, right. So, at that time again input editing is going to be very important. Then sometimes during processing also you can control errors. You can control errors. See, this is why it is always better to include little bit of redundancy, right. Suppose you are giving your bills, say TADA bills. Suppose you have gone out for some trip for let us say 1 week, and you have given a bill. Usually those bills are given first of all day wise and then item wise, alright. So, day 1 travel, then local travel, food, etc., etc. Day 2 travel, local travel, food, etc., etc. So, what may happen, you can always compute a day wise total and you can also compute item wise total, right. So, how much you have spent on Monday, how much you have spent on Tuesday, Wednesday, Thursday, like that, or otherwise how much you have spent on travel, how much you have spent on local travel, how much you have spent on food, etc. Now, if you sum it over the days or if you sum it over the items, that is you get the grand total, that is the final amount you are claiming. It should be same both ways, alright. Now, if it is not same, that means one of the calculations have gone wrong, is it okay? So, these are called proof figures, or basically these kind of calculations can check what is known as processing errors, is it okay? And I have discussed about portability, and maintainability also should be very important. How to improve maintainability? By improving visibility. What is visibility? So that the program is very easily readable. Anybody reading the program should understand the code, alright. How to do this? By first of all proper indentation, gapping, it should be properly oriented, all if then block should begin with similar positions, alright, and comments, and very important thing, naming of variables. Most of us when we write a program, we do not give much importance to the variables, naming of variables, but is an extremely important thing. The variable name should be exactly what the variable is and not any fantasy name that you may think of at that point of time. Then there are 3 important categories in which we can classify program. One can be called a correct program, reliable program, and a robust program. See, these concepts of correctness, reliability and robustness is universal, is not only for programs, it could be for almost any other concept. So, you may say design, correct design, reliable design, or a robust design, alright. Usually the word correct is used whenever the particular thing meets the specifications, alright. Something that meets the specifications is a correct program, alright. The reliable program on the other side, it should perform satisfactorily for a wide variety of correct or incorrect inputs and operating conditions. So, what is a reliable program? A reliable program, it should perform over a wide range of inputs and operating conditions, but please understand it is still within the system. You can vary the input. You see, something like, suppose you have an electric bulb, alright. Now, this electric bulb is most often until unless some very peculiar thing happens, is burning at maybe 200 to 250 to 60 volts, alright, and with normal operating conditions. alright. There are not much of other external disturbances, the voltage is steady, there are not too much of fluctuations, alright. But you might have rated that particular bulb for 140 to 260 or 140 to 300. So, whether the bulb is reliable or not, it has to be tested at 140, at 300 and at all possible voltages, alright. The concept of robustness is reliable program that performs satisfactorily in unknown conditions. See, this is called a robust design. Usually what happens, suppose a human being, suppose we say that human being can withstand temperature between, let us say, 0 degree to 50 degree. But suppose you have been put in 55 degree, what will happen? You will not melt, you will be uncomfortable, you will feel very bad, but at the same time you will still exist. But suppose your bulb, which is rated at 140 to 300, suppose you give 301 or 305, and if the bulb immediately goes out, you cannot blame the company, because the bulb was not supposed to run at 305, it is supposed to run up to 300. But it does not mean moment it becomes a little higher than 305, it should immediately go out. Is it all right? So, that is usually this is a Japanese concept that even in situations which is beyond your operating conditions, it should not behave in a peculiar manner. I mean, it should not simply go out just because you have been out of range. It should still show a reasonable behavior, like what happens to human being. So, that is a kind of expectation, all right. Now, let me give an example. I think I am late today, but still these example should be given, I feel. This is about the difference between correctness and reliability and robustness. Now, I think I have discussed little bit on what is reliability and what is robustness, but not much what is actually correct, the correctness. You see, this is about a very simple example about the design of a swing, all right. So, specifications given was that, suppose I have a tree here, and basically this is what was expected. This is what was expected, that in this tree you put a swing, all right. But it was given in a different way. See, this is a diagram, so you all understand what it is. But when the specification document was prepared, it was said like this: the swing should be made of wood, all right. It should have supports supporting the wood in such a way that it should not fall. It should be put on a tree branch which is sufficiently strong, and finally it should swing. All right. So, what happens? The company made the swing, all right. They made the swing, and everything was done very nicely, but it was a little bigger. So, what they did, they put it on the tree in this way. Actually, the tree was not very big, so they could not put, because when they try to put it on this side of the branch, then they find that branch is not strong, so it could not be done. So, they did it like this. All right. So, this is how they put the swing. Now, see, they were claiming this is a correct swing. Why it is correct? Because it is put on branch which is strong enough, this is made of wood, and these supports are strong enough to hold a person who would like the swing. Then the people said, no, 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 it is not correct swing because it is not swinging. While I try to swing, it hits the tree. They said, okay, I will fix that also, but you may have to spend a little more. Okay, no problem, some more money is released. So, a very ingenious way they have done this. You know what they did? They cut the tree into two parts. Alright. From the then they have to build two more supports, so that the top portion of the tree still remains and the swing is mounted in between. It is swinging, you see, it is swinging, and the tree is cut, and these supports are required so that it can be supported. So, this is an example of a correct swing. Alright. The swing is definitely correct because it serves all the specifications, alright, but it is definitely not robust or reliable. Although, see, this looks like an extreme example, but unfortunately many of the programming or many of the application software solutions that we give in real life may be like this, right. Unfortunately, I cannot begin the coupling and cohesion part. We shall do it on the next class.